Hello, everyone, and welcome to the first interview episode of What's New in Cloud FinOps in 2025. Got that right? Right. Yes. We are going to talk about the past. We're going to talk about the future. And to do that, we've decided to bring an expert that understands text, checks, value, benchmark, everything. And that is Anthony. And as usual, I am here. I'm Franck Contrepoix, and I am with my great friend
Stephen Old, and very excited to have our first interview episode of the year. Our next news episode will be out as soon as it's recorded. And great to have Anthony back, because I found the episodes of Anthony in the past have been some of the most interesting, as in, like, we've learned stuff that really surprised us every time. So great person to get back to the review of 24 and the future of 25.
And so introduce yourself, Anthony, a little more for our auditors.
Firstly, thank you very much for hosting me. I'm Anthony Monte. I'm the founder of Cloud Mercato. We are a small consulting and research firm dedicated to the study of the cloud market. So our idea is that we're looking at all the cloud around the world, their products, their services, and more and more. And we share that on our platform almost for free. Do not cry if you get to pay something, but almost all our data is free. And so happy to be here to talk about cloud.
Excellent. So obviously, first question is about the past. What happened in 2024? Oh gosh, I got lost. When were we? What year is this?
Yeah, 2025 now. You're doing perfectly, mate. You're doing perfectly.
Yeah. Perfect.
So what happened then?
What happened then for me? I think in the beginning of 2024, we see a lot of things about GPU market. Tons of GPU-only cloud provider came in the market, and their value was, we are NVIDIA premium partner, NVIDIA platinum, silver, gold, or other metal partner. And so plenty of GPU for running AI everywhere. And the idea was that if I would like to have an H100 or H200 GPU at AWS, Google, or Azure, it will be close to $8-9 per hour. And all these cloud providers had $2 per hour. So you divide the price by 2 or 3, depending on the cloud provider. And it was nice because a lot of competitors came in the market. But 2025 maybe will be another story.
It's interesting, the AI market and stuff, because so many people are still only just getting started with AI, aren't they? They're not even training their own models yet for a lot of them, and then when they are, they're hitting this piece. But when I've looked at it, so I sit on a working group for AI and stuff. People aren't automatically going to the cloud for it. They're seeing that the hyperscalers are expensive. People are really considering on-prem and other alternatives, probably in a way that we've not seen for the last 5+ years. You know, the answer has always been cloud for so many organizations, hasn't it? And we're maybe finally seeing something where they kind of go, where should this sit? And I don't know where that cognitive approaches come from, because maybe people should be doing that for more of their workloads, right? But there definitely does seem to be a wider spread of where people are looking to put these workloads, and I think pricing from your side looks like a real driver for that, right, Anthony?
Not only pricing, because they all see the privacy of data.
Yeah, true.
Maybe it's the first thing, because a lot of companies said to their employees, you cannot chat with ChatGPT. It's not possible for us to send any data to any data to any provider. It could be ChatGPT or DeepSeek or whatever.
Copilot, whatever,
yeah. And so it's more or less easy at the end to make an inference system at home. When I say at home, it could be your own home with your family, or for an enterprise. So people are doing it, and in fact, it evolved. But at the beginning, when you look at the catalog of hyperscaler about GPU, I'm talking about YAS, not the advanced path things. And when you look at the GPU catalog, you can see that they offer, for example, a bundle of 8 H100. You cannot come and say, I would like just one. It evolved, of course, but at the beginning it was like this. So if you would like to have a recent GPU, you get to take 8100 and you get to pay 50, 60, 80 per hour.
Yeah.
If I just would like to have a chatbot, I don't need to have 400 gigabyte of VRAM on my GPU. I can make a chatbot with a V100, with a A100, and even if you take a T4, you can do not a big LLM, but you can run your LLM. Now, depend of the scale that you would like. But talking about pricing and this kind of thing, if you take Hugging Face, for example, we all know Hugging Face. It's the GitHub about AI models, data set, and more and more.
Yeah.
When they made a small paper about their infrastructure, and most of their infrastructure was AWS T4G. So it's old NVIDIA GPUs released maybe 6 years ago, and it's Hugging Face. It's not like it's a self-host at home or whatever. It's Hugging Face. They are delivering things for their clients. They are doing embeddings. They are doing more and more services. So you can use old cards and make your infrastructure at home for your purpose. Now, when it begins to be complicated, it's for the training. And most of the users don't do training.
And that's the thing. So this is beginning to remind me again of like old supercomputer stuff. And I built a framework around like cost-effective use of modeling and AI. And one of the things was around like if you are regularly training models, then you should be doing them in series rather than parallel, and then you can kind of cover the cost of that potentially by having some sort of reservations and things if you're training that regularly. Now you've got to be of a size and a real focus to be training that regularly, or have models that just to be valid need regular training. But there's been a lot of announcements and stuff that we've seen in the last year, Frank, around things that specialize in fur and specialize in this kind of thing.
Even CPUs.
Yeah, exactly right. Do you think there's a relative level of kind of parity across the market in the quality of the products? Like I know you guys do a lot of benchmarking. Is it apples and apples, or are there places where if people are doing this in a serious way, they're better off looking at certain providers, or they shouldn't be looking at the cloud at all? Like, what's your thoughts on that?
We are talking about quality of models or performance of different models. When I think about quality, it's about the quality of the answer and the performance. About quality of answer, for me, we are in 2025, we reached the plateau for me. We have something like 5, 6 big names, DeepSeek, OpenAI, and more, and they are racing to have the best AI. And if you subscribe to DeepSeek tomorrow, in 2 weeks, there will be another AI outcoming, and you will say, okay, I won't take 2 subscription, but okay, it's on demand, I will take 2 subscription. Okay. And 2 weeks after, there will be another. So talking about the quality, I think everyone is pushing the thing. No one is really, really better in anything, in everything. So we cannot really compare, make benchmark. It evolves every time.
What about the pricing benchmark of training your own model? Like, is there a better cloud to be using to kind of get like performance versus cost in when you're using when you're doing the training itself, when you're running your own models?
I think you should take a strategy of the real strategy of the cloud, be on demand. Okay, I would like the DevOps are doing in CI/CD. My dev is doing a commit, he push the code, and the pipeline will do everything, the test, the unit test, the functional test, and push the code into the upstream repo. We should do the same thing for AI, and we are doing the same thing for AI. In fact, you would like to train, so you change your data set, you push your data set, and everything will train. But the problem with that is we are thinking about, okay, I add 1,000 line in my data set and it will train my AI. You can do it at home, no problem. But how do you measure the quality of your change? And basically, when you look at professionals at Meta, at OpenAI, and more, when they do a change on the model, they can train 20 instances of the same model at the same time with different parameters. And after they only take the three best, and it's just a checkpoint, and they continue, and it can make 2 weeks. If we are talking about an operation that takes 2 weeks, maybe cloud is not the solution, because it seems that you are 24/24 7/7. So maybe cloud isn't the solution, and that's why you should buy a GPU by yourself and doing it at home. It's my opinion.
And doing LLM. So if you do your own model, but let's put it the other way. I think there will be lots of specialization into the thing, so that you will start. So it's already happening that you have new models. I think we were talking DeepSeek using that you have this group of experts. You have different AI, and each one of them is an expert, and each one of them has been trained by using other AIs anyway, because you don't have enough data online. So that's madness, but yes, brilliant. And so but at the same time, you can see that there are, we all need a specialist. We have very few needs, especially when you use something. And I think that's where Apple got it reasonably right. They say, hey, I have an iPhone. That's the power I have. I'm going to help you creating emojis, because you like to send emojis, creating your own pictures, and summarizing your emails. And I'm going to use your data that's on the phone, which I'm the only person having access to. That's the training model. But I'm going to limit it to a certain number of things, which I'm going to do well. The rest is going to be delegated to someone else. And I do think that building a model, I think it was with Matt from AWS, it was at the time, now he's PwC, the head of AI, and he was saying, yeah, we know it. Creating a new model costs tens of millions. Fine. Now, the question is, we don't need those full massive models. And by the way, I think I tried a Mistral at one point. I took the bigger one, and to get 10 words, my computer took 1 hour and a half to get an hour. Now, okay, no, that's not good enough. But yeah, you do. I do believe we're going to go to a specialization, and people will start having very specific, very well-known tools that are going to succeed. Coding. Yeah, Python coding specialist, or lawyer specialist, or supply chain optimization specialist AI. And the overall one, the one that created all the hype, is really cool, but it's too generic. And so we'll find it hard to find a use case that really applies to it, except answering my stupid questions and never be bored to answering my stupid question, which is a brilliant thing.
Just give it to a child.
I agree with you. The thing is that for me, all this LLM hype is just an hype, and is quite useless compared with what we really do with AI. I mean about science, about the universe, about plenty of things about physics that we are doing with discovering with LLM are really useful. Now talking with ChatGPT, etc., it's fun, and it will create a lot of dinero of money, but I don't think it's the real revolution of AI to be able to chat to a robot.
Yeah, indeed. And I mean, on the kind of carbon conscious side of it, this kind of useless use of it is horrific, right? The amount of power consumed by these specialist chipsets, right, Anthony? It's massive. You know, it's a big step up from, you know, like you were saying, like running it at home, which you could do a load of this stuff to be able to answer, you know, the kind of nonsense maybe you want to answer. I can't remember who it was for. Computer Weekly or someone interviewed myself and a colleague about like the increase in cloud emissions that's come from three cloud vendors. Well, it was for two of the cloud vendors. I believe it was Microsoft and Google announced that theirs had gone up by like 30-something%, and that they were putting this down. This wasn't expected, but it was putting it down to AI. It's so expected. Like if you've doubled down on AI like you have, your numbers are going to go up for carbon. And when you've then got, you're trying to throw it in people to use in every way, because
Yes.
both of them have AI tools that you can use and do all sorts of things with, and people do test and play with them. And then they are quite expensive for an enterprise to take on, like, 'cause that's what they're trying to do. You can play with it and then take the enterprise version. That's where we'll make our money, because that's how these companies all work, and that's fair enough. But the amount of things that they end up being useful that isn't particularly efficient might not be seen to have like that massive cost impact, but the carbon impact is massive.
Yes, and you can see how that usage is just growing. They are building, so the cloud vendors let's put this two things. First, they are building specialized tools, so they are also trying to figure out what this is for, which is one thing. But on the other side, they are allowing you to not worry about cost really in a serious way. If you were to buy an NVIDIA and it's 30,000, you start thinking twice before you buy it. Okay, you're starting maybe not. Well, we'll do this AI stuff later on. All of a sudden, you can use it. So everyone is on board. Everyone is using chips that, if left to their own, including myself, if they were left to their own thing, they would never buy. And at the moment, most of the AI companies are losing money, are losing tons of money. Yeah. So it's not even a model that works. If I were paying the costs probably that I'm generating for OpenAI in particular, I would probably not be a customer. It would just be too much. So yeah, there is. It's a very interesting thing, and the green bit now interests me way more. Just one little thing, which is, remember, guys, we know the future. Skynet, if you remember.
So true. But my wish for 2025 is that people open the eyes on the existing hardware that we can use for AI. Currently, we are using GPU, so we are taking. It's like we are taking a brush for painting, and we are doing numbers and mathematics with that. It's a bit like this. It's not efficient. It's working okay, but it's not efficient. And on the air, we have the NPU, we have the APU, we have the IPU. We have many solutions and also, of course, since ever, we have the FDPA. Not really adapt to everything, but for a lot of usage, maybe we can take the most adapt hardware. And for instance, I was talking about self-hosting, making things at home, etc. Personally, even if I'm a bit blocked on certain things, I prefer to using Apple hardware for making AI at home than having to take a real PC with a NVIDIA card. Currently, the latest NVIDIA, the 5090, it's close to 500 watts. So I don't want to have 500 watts on my desk here just to be able to chat with a robot. Yes, it's my house. It's not I'm not a factory. So, and here I'm running AIs, LLMs on my on the Mac Mini. It makes something like 6-7 tokens per second, so I'm able to chat with it without any uncomfortability. But I know I will have maybe 10 times this performance with an NVIDIA card, but the ratio of token per second versus watts, I prefer to consume 20 watts rather than 500 watts.
500, yeah. That's a really, really good point. I think back in the old days where people ran data centers, whether it was co-location or their own, they really understood the electricity and the power drain and the draw. Again, that's another thing that's been obfuscated, right? We just don't see it anymore because it's all, I don't know, that's the stuff you do in your place now, Frank, but it used to be one of our key metrics.
Yes.
Like ampage used to be a key metric of IT, and it's just gone.
I have a friend who is in some form of helping build a data center, and he was telling me one of the big issue is the cables, the power cables coming to a rack. He said now they can help you with 4 servers, 10 servers max. I say you have 40U, so you can put 40 servers, but he said the power out is just so mad that you can just we've lost that efficiency on power, or we've increased so much the capabilities of our servers way faster, like the good old ways of IBM PCs. I mean, I remember some servers spending 1,500 watts, which was complete madness. But it's still there, and AI is making it harder. If you put an NVIDIA card, all of a sudden you can put a third of the servers into a rack for the same heat, for the same everything. So you need to expand. You have the real estate might be the thing that's going to stop it. But the cooling also must be horrible, not just providing that power, but also cooling all that stuff.
Yeah, it'd be interesting if it impacts. So we have the concept of PUE, right? Power utilization efficiency, which is the things in your data center. This is for the listener, not for you two. The things in your data center that are outside of your server's usage, and then you basically increase the server usage by that number to talk about the efficiency. If a data center has more GPU and therefore potentially requires more cooling, will it make the data center more efficient? And will we actually see a potential move in PUEs in these data centers versus history? Because that's one of the only ways we can see cloud efficiency, is that they generally have very good PUE numbers. But we would anticipate, as they increase the amount of GPUs, can they keep up their improvement of efficiency at the same rate as their new requirement for cooling? I know it's largely water based, but it's still power that's needed to do it, and you've got your hot and cold racks and all of this. It'd be interesting.
Yeah, it's interesting.
Yeah, I don't think. I think the PU will increase with all the GPUs coming. And when you listen to the NVIDIA CEO, he's saying that data centers should be measured in token per second per gigawatt, something like that. So the paradigm is outside.
We can't worry about power now. Yeah, we can't worry about power now because there isn't enough in the world to power all the GPUs we're trying to sell.
But at the same time, you understand, but this means that the only reason for existence for a data center is to generate AI tokens. So he has a view about that. Because that's why they're hired to build.
Good for him. Yeah, I wonder if that would be good for him if that's what happened. So let's bring it back from AI for people who have moderate budgets and are in the real world. Let's just go to what we expect maybe to see in the normal instance families and VM families in the cloud. Obviously, and last time you were on, which was our 3rd anniversary, so that's about a year and 3 months ago or something, you pointed out something that we'd never noticed, that the 7As in AWS had jumped by like 34%, did it work out to be, while the Is and the Gs were 5% and 6.25% in that. Before we came on there, you talked around that we've obviously got the 8Gs that came out in 2024, but we don't know what else is going to happen, right?
Exactly. I think it was in December or November, AWS released the M8G, so the latest generation of Graviton server on their EC2. And it's nice. We still have a good pricing, but we don't see the Intel and AMD coming. And so basically no one is waiting for them, in fact, because the latest performance of the AMD and Intel, the M7A, M7i, were good. I measure it, so I know, but people will see, there is the M8, it should be better than the M7, and they will buy it. But for AWS, maybe they can stay like this and make benefits with another version.
Yeah, I remember you saying the 6A was the most price performant at the time of the last one, because the 7A had gone up in price so much. And versus the 6A was still a really good place to be in terms of price performance back then. Does you still have that view?
Yes, but if you remember, they also released the M7i Flex.
Yes.
And this modification, I don't know where they want to go with that. It's not
us
really
too.
clear. It's not really clear in the documentation what they mean with this about CPU consumption usage. So I was waiting for a new generation to be clear about are they continuing this, or will they dedicate a new kind of instance for that? I want to see what they are doing.
Could it be that they are managing to generate, because it's ARM and in their environment, they are generating more generations of CPUs, in this case Gravitons, faster than Intel and AMD. So there is nothing new to put into an M8. And so you just wait. Maybe we'll jump to the M9 for everyone together.
Yeah, there might be a 9G before there's an 8 an AI or 8. I mean, have we seen that Intel or AMD have released a new chip generation?
I think they are Sapphire, Arc, or whatever. They are small because they are faster than before, at least at Intel. And you're right, because if you look at the T instances, currently we just have the T4G, and that's makes something like 3 or 4 years we have the T4G, and there is no T4i, T4a, or whatever.
Okay.
So
yeah, that's true.
Maybe like Apple did with their hardware, they will just drop Intel and AMD by default.
And they'll only do them every other generation.
When their instance will be old, they will replace it. But I did some several benchmark during the end of 2024, comparing AWS VM and other cloud provider. And because their other cloud provider didn't have ARM VMs, I got to test only the x86, excuse me. And AWS still have very good performance in terms of CPU. I compare with some cloud provider with a very recent hardware, and AWS hardware is still good. So they really don't need to buy new hardware at Intel and AMD when they have their own hardware to develop. And I think they prefer to have a short cycle to be able to sell, develop, rather than buying AMD CPUs.
Do you so let's just dig into Graviton or ARM in general, right, across the board. A lot of people move to them straight away for their managed services, i.e. their RDS or your Cloud SQL, whatever it might be, depending which cloud you're on, right? I'm seeing a few more people actually investigate moving more general workloads and looking whether they can take their workloads that were just running on, normal infrastructure, IaaS. Do you have any advice at the, where the x86 or either way around, where the ARM stuff is better, like the type of workload that it suits better? Is it better for things that need to load quickly? Is it better for more stable stuff? Like, what would you advise people on? Because I know you just do so many different types of tests of different types of chips.
I would say that ARM is the future, and everything still should run on ARM. Now, what are your restrictions? Only your proprietary application that you cannot compile by yourself. Except that, you can run everything. Maybe Windows have some issues with ARM. I don't know about Windows for sure. But currently, my benchmark, every open source benchmark, I can run them on ARM. On top of that, about AI again, you can run plenty of AIs directly on ARM. Of course, it won't be the performance of a GPU. People are working on it. I invite you to look at I think it's DeepSparse. It's a small framework to countryside things to be able to run them on a CPU. They have good performance. And I don't see anything that could be really when you really have to use Intel or AMD. Currently, I advise to everyone to use ARM when it's possible, because it's about firstly pricing, and next it's
Yeah.
about power consumption.
Yeah.
An ARM is 20 watt, an Intel is 100 and close watts. So there are
Where does the AMD fit in between? Because I normally thought they were lower than Intel, but not as good as ARM.
it's not really lower. It's more about the plus of AMD. It's that they are a better density, an higher density of cores. So it's better for the cloud provider, but I don't care. I'm buying a virtual CPU.
Yeah. But if you're buying your own kit, you'd be able
Exactly.
to drive better density. Yeah, fine, that makes sense.
Exactly.
I think,
and I was looking, I think there was one release in 2024 from AMD for server processors, and that was in October. So there was nothing between 2023 2024 almost. So there's probably, but there is once a year. And so, but I'm pretty sure that following NVIDIA example, AWS has 3 teams working parallel, and almost every 6 months they can release something, or they have something new to add to the plate. Making it a race where anyone on ARM is going faster than the other ones. Also because they don't care about compatibility on the path. It's fun because it's again, you do the circle back. I come from a world where you have the Sparks, the Power PCs, and it was all different. Then, finally, we have only one type, x86. And now again, everyone's got their own and everyone is different. And while we say ARM that's a basic architecture. That doesn't mean they are compatible. You cannot exchange one ARM for another, not easily. But Microsoft is also moving to ARM because I think the latest, I've seen that the latest computers, the Surface, were based on Snapdragon or something, possibly. So they are there, and they were already there for quite a while. The kernel is quite good for this kind of stuff.
Exactly. The thing is that firstly, for Microsoft, they have since ever they have playing with Windows and ARM. We can see Windows Phone, it was ARM, Windows CE, and more and more. On the cloud, they are using Ampere processor to be able to make their. I think it's for instance, you take the D instance at Azure. There will be the DP instance, which will be their ARM instances. Google also, they are doing their own ARM processors. I think recently they released the C4D ARM instance again. So everyone is moving on this direction. If I am a cloud provider, like we just said 5 minutes ago, my main issue as a cloud provider is firstly the cost of my hardware, and next the electricity consumption.
Yeah.
So by buying ARM, one problem is half solved.
Yeah.
And it's also they really do care about the density. So if you can custom made them, so we got to a space where the scale of the cloud vendors, the hyperscalers, makes it interesting that marginal winning, that 1% better, is as value. If you improve by 1%, the speed of my computer, I probably will not notice. If you do it on the scale of hundreds of thousands of servers, it changes everything, or it changes a lot at least. So
on top of when you can read that AWS is planning to build nuclear reactors.
Yes,
the circle is met.
I
told you, Skynet.
Yeah.
Let's be optimistic.
Yeah, I'm just conscious of time. The only thing that I found interesting across the last year and will be interesting moving forward, and I'd just like your thoughts. When we found that AMD increase in AWS, we then went and researched when the equivalent Azure instance came out, whether the same thing had happened, and it hadn't. And so it wasn't that the AMD price went up. It was that the AWS price for AMD went up. And I went and spoke to some of the AMD guys, because we know some of them at the AWS Summit last year.
Yeah.
And I said, hey, why has the price gone up? And they were like, the price has gone up? And I was like, yeah. Like on AWS versus Azure and all this, it's jumped up massively. And it wasn't a pricing point for them because they have no control over it. But what I found interesting out of that was that we did see a patch 2-3 years ago very regularly, where they seemed to be getting closer and closer in how they were pricing. When one went up, like it was almost like following each other on tracks. That seems to maybe have stopped. If we look at spot instances, Microsoft's are significantly cheaper than Azure's to an extent, because one there's like 90% discount, one's like 65% discount. Sorry, than AWS's. So it's actually can be 3 times more expensive to run a spot instance on AWS than on Microsoft. Now you do have the 30 seconds versus the 2 minutes, but in reality that doesn't make a massive difference anyway. There's not much you can do in 2 minutes that you can't do in 30 seconds. And so that's where AWS used to be. Obviously, it used to float. That's why it was called Spot, because it was a floating point. But now it's not. It's a black box. They've both gone kind of black box pricing, but Microsoft haven't gone, do you know what? Let's follow the market and squeeze up to 65% instead of 90% discount. They've stuck, and that, last time I checked, which was probably in December, they'd stayed down there, and they have for a year or so since the difference has been in. So we may be seeing a bit of. We've always seen Google do slightly different things, but we maybe are seeing it where they're not all trying to be the same on pricing, which they really seem to be like a not a coalition, but alignment for a while. It now seems to be the opposite of converging again, diverging again.
Yeah, and I do think, based on what you say, is probably that Microsoft is way more is following the market kind of approach, because they are keeping their server. So I do believe that Spot is here just to keep servers turning on, because they never break when they're on. Always when you turn them on. So hey, I have too much stuff. Yeah. Well, AWS is trying to push people more and more to on demand. And so the benefit. Or committed, but for me, yes, the idea is that you move people, so that it's even 65%, even 3-year commitment. You are not that far from this. Yeah. And so you end up they are trying to make sure that they get the revenue that goes with it, that goes with people being on demand.
Well,
and the Spot is
headroom's a bigger risk as you get bigger, right? So they always had to keep a level of capacity to make it look like they were elastic and endless. Yeah. But as you get bigger, the size that needs to be to still be effective and efficient shrinks versus the size of your wider revenues. Yes. And therefore you don't need to give as big a discount on it because it's not as big a risk.
And the growth was not as big as in the past. In the past, you had really no clue how big you could have doubled the people using the cloud all of a sudden in a year, in 6 months, in 3 months. Now seems to be reasonably stabilized. If you look at the latest numbers, they are not growing as fast as they used to.
Something like that. It's
over a year. That's what 2% a year, a month. That's organic growth. So you end up. I think that there is a chunk of that. They have extended their life. They've extended the life of the servers. They've so there is lots of work. People are moving to Lambda, which also is it older hardware on Lambda? I don't know, but I do think so. So you have lots of things happening there that makes Microsoft still fighting to become the leader, and so they can go and they're probably overbuying. Amazon seems to be more careful now, I would say, with their content or the stock.
But it's interesting. We know so much about these companies in some regards, right? Especially when we've got Anthony with us, I feel like we know more. But we still know nothing. Like, so much of this is our assumption of how it's working behind the scenes.
Absolutely.
From years of experience. But it's still a big black box, what's going on once you go through those data center doors, right?
Yeah,
agreed.
Yeah.
Go Anthony.
I can look at any cloud provider from the 4 corners. At the end, I can only see what is public. I can dig some file information, but at the end, it's the OSINT, the public data that they let available for their user. Yeah. And next from this OSINT, you can do some assumption, because you see that and this evidence and that, so you can think about things. But at the end, they don't chat with me. I've got relation with maybe 50 cloud provider, but never had a meeting with AWS.
Yeah, and yes, and I'm so now I've moved to a new company which is called Green Pixie, and part of the thing we do is a methodology around GreenOps or the carbon emissions for cloud vendors. And yes, there are lots of assumptions, as you say, because you need to find proxies. You need to find ways to say, yeah, you run a firewall this way. That would be the most efficient way. So probably the way cloud vendors are using it. And because there is nothing there.
Yeah. Someone asked me recently, to help them to develop their methodology for working out what their load balancers were using in terms of carbon, the emissions, because it's an ELB service, right? Or an ALB service. We don't know what hardware's under that. We don't know how many people are going through it. So all we can do is do comparative requests of what running something on-prem would be, put that into their PUE. That it is a big challenging black box.
In my pool of prospect and customer, there are a lot of people coming to me for data about cloud provider, and especially green data. So it could be about electricity consumption, power consumption. It could be about different aspects of things and anything I can collect. And the thing is that when you look at the European cloud provider, I'm talking about French one, it could be from Finland, it could be from Switzerland, and more and more. We try to be transparent. We try to be able to say we have X machine, this machine use X, Y, Z, and more. Maybe they don't all have a thing on their website where you can download your CO2 consumption, but they try to be transparent. When you look at American cloud provider, and mostly the hyperscaler, they try to be transparent, but with a report of 80 pages when you can read everything that you don't know. Basically, you have 50 pages and maybe only 2 graphs are useful for you in all these reports. And a lot of promise, a lot of wish, we will be this in 2030, we will be that in 2050. It's cool, okay, we have this return, etc. But the transparency is absolutely not the same in US and in Europe.
Yep.
And so from this, I think the Europe have a step forward, but let's see that in the future in 2025.
Yeah,
cool.
Agreed.
I think we're done there because we
had
an amazing chat, and we could continue for hours. But
yeah.
The thing is that we can always say that in French it's in France we do not have we do not have oil, but we have ideas, and
as many as you want.
It's that okay, we don't have the capacity of the American one, but with transparency, but maybe the monetization of this transparency, saying that we are doing like this, and it will consume, 8,000 grams of CO2. Now, the French cloud provider is telling me what is going on their cloud provider, on their infrastructure. If the American one don't want to tell me, I will take the research about what they are doing, and we'll take the worst number available and say, okay, if you don't want to have the worst number on this report, just give me the real one. And it's how everyone is doing. Okay, we don't have the number, so let's take the worst one possible.
Cool. Perfect. I'm just conscious of time. Thank you so much, Anthony. Interesting as always. I do want you to be our inaugural. No, every year I want you to be our reviewer. It's ideal. Because we're all in the same world, but you have a really different lens on it, and it's so detailed, so knowledgeable. I really appreciate that. So thank you again for being our friend and for being on the podcast again. Frank, great to see you. I'll see you on Monday where we record the next news episode. And I guess thank you everyone for listening. We're excited to bring
and for the patience.
Yeah, and the patience. Yeah, thanks very much.
Thank you.